feel the vibe.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we explore polynomial division and its uses a little bit further. So previously we have worked on long and synthetic division of polynomial functions. Now we're going to get into some theorems that relate to polynomial division and remainders and factors. So when you dealt with theorems in geometry, you use those theorems often as evidence and support for the work that you did. In Algebra 2, that's not going to be the case as much as it's just going to give us a thought process to follow as we start to explore values or information about polynomials. So let's go ahead and take a look at problem number 4, which is actually going to lead us into what we call the remainder theorem. In problem number 4, it says complete each of the following to discover the remainder theorem. So what I want you guys to do at this point is I want you to pause the video and complete problem number 4, A, B, and C, and then when you're done, play the video and we'll go over the answers. So hopefully I've had a chance to look this over. In problem number 1, it says evaluate f of -1 for the function. So remember, this notation means that we are going to input -1 as a value for x. So I'm going to do that over here in the calculator so that you can see that work. And we'll find out that f of -1 equals -4. Then in B, it says evaluate this division problem. I'm going to go ahead and do this using synthetic division because it's going to be a little bit easier. So I'm finding my 0 first. X plus 1 equals 0. Solve for x, subtracting 1 from both sides. So my 0 that I'm going to use for synthetic division is a -1. So your -1 goes on the outside of that synthetic division. Then we're going to take our coefficients and we're going to put that on the inside. So the coefficients of the dividend would be 1, 3, and -2. I'm going to go ahead and put a box under -2 because that's my remainder. I'm going to complete synthetic division. So I'm going to add down the column. If I add down the column, there's nothing to add to 1, so that result would just be 1. Now I'm going to take this result of addition and multiply it times the 0 of the divisor. So -1 times 1 is -1. That goes in the next column. I'm going to add down this column. 3 times -1 would be 2. That result is going to be multiplied by the 0 of the divisor, -1. -1 times 2 is -2. I'm going to put that into the next column. Then I'm going to add down that column, and there we have a remainder. So if I compare B to A, what I may notice is that the 0 of the divisor was -1, which was actually what I substituted into the function. The remainder of the synthetic division process was -4. This leads us into the remainder theorem. The remainder theorem says that if p of x is divided by x minus c, then the remainder is p is equal to p of c. Essentially here, if I take any polynomial and I divide it by a linear factor, the 0 of that linear factor is, if you put the 0 of that linear factor into the equation, that's going to give you your remainder. So these two operations can be switched, essentially. If I want to evaluate for a function using synthetic division, which we generally won't because that's a longer work process, but if I want to evaluate for a function using a synthetic division, I can take that value and complete synthetic division, and that remainder is going to be the same thing as if I substituted that value in. Conversely, if I wanted to maybe not just divide, I wanted to find out if I have a remainder or find out what my remainder is. If I look at this division problem, I could just take the 0 of the divisor, -1, and substitute that into the equation, and if I do that, that's going to give me a remainder. So this process is going to shorten some things up for us later if we remember this remainder theorem. So substitution and evaluation for values can be replaced with synthetic division and vice versa if done correctly. So let's go ahead and take a look at problem number 5. It says use the remainder theorem just to evaluate each of the following at the given value. So again, this is probably the only time we're going to do this because this process is longer than substitution. But if I want to figure out what f of 2 is, I can do synthetic division with 2 as my 0. So I'm going to take my coefficients, -1. Remember, there's no x squared there, so I'm going to put a 0. I'm going to put a 6 in front of x to the first power, and then I'm going to have a -7. Then I'm going to compute the process of synthetic division here, adding down the columns. Nothing to add to -1, so I'm just going to bring that -1 down. I'm going to take that -1 times my 0, 2. So 2 times -1 is -2. That result goes in the next column. I'm going to add down the column. 0 plus -2 is -2. Take that -2 times my 0, 2, which is -4. That goes in the next column. Add down the column. 6 plus the -4 is 2. Take that result, 2 times my 2, my 0 of my divisor, 4, that goes in the next column. Add down the column, and I get -3. So f of 2 is -3, or should be. Now we can check this. We can check to see if we've done this correctly by taking a 2 and substituting this into the equation, which again is generally going to be the method that we prefer because it's faster. But if I take a -2 cubed plus 6 times 2 minus 7, you'll see that the result is the remainder, -3. So go ahead and pause the video and see if you can complete the same process for B. In B, we're trying to evaluate for 7. So essentially, we're trying to find f of 7. And we can do this through, again, synthetic division. So my 0 of my divisor would be 7. My coefficients would be 1, -47, -16, 8, and 52. Completing the process of synthetic division. Add down the column. There's nothing to add to 1, so I'm just going to bring that 1 down. Take that 1 times my 7, which is my 0. 1 times 7 is 7. That goes in the next column. Add down that column. I would get a -40. I'm going to take that -40 times 7. -40 times 7 is -280. I'm going to add down the column. So -280 times, -280 plus -16 would be a -296. -296. I'm going to take that times my divisor 7. That result would be, I'm going to run out of space here a little bit. Oh, sorry, I made a mistake here. I forgot. Hopefully you caught this. I forgot my 0 placeholder. So my coefficients should actually be 1 for x to the 5th, 0 to x to the 4th, then -47 for x to the 3rd, -16 for x squared, and 8, and finally 52. So sorry about making that mistake here. Let's see if we can fix the process. So still, my divisor is 7. Still, I'm going to add down the column and bring down my 1. Now I'm going to take 7 times 1. That's 7 goes into the next column. Now I'm going to add down that second column. 0 times 7, or sorry, 0 plus 7 would be 7. I'm going to take that result, 7 times my divisor 7, which is 49. That goes in the next column. Add down those, the -47 plus 49. Add down that column. The result is 2. I'm going to take the 2 times my 0, 7. That result, 14, goes in the next column. Add -16 to 14. That result is 2. Take 2 times 7, which would be 14. That goes in the next column. Add down 8 plus 14 is 22. Put that into the next column. Oh, sorry, made another mistake. Back up here. This -16 plus 14 should be -2. Boy, 2 mistakes. Hopefully you caught them both. Now let's take the negative 2 times the divisor 7. Sorry about that. Should be a negative 14. Negative 14 plus 8 should be negative 6. Here's my remainder. So 7 times negative 6 would be negative 42. Add those together, and my remainder should be, if done correctly, should. So f of 7 would be 10. Now again, we can check this in the calculator. I'm going to do 7 to the 5th power. Then I'm going to do negative 47 to the 3rd power, or sorry, times 7 to the 3rd power. And I'm going to do negative 16 times 7 to the 2nd power. Then I'm going to do 8, plus 8 times 7. I'm going to add 52. And I made a mistake here as well. Boy, let's try this again. 7 to the 5th minus, there we go. Let's see what I did. I hit a times instead of a minus there. So let's fix this. Delete that out, change that to a minus. And now we should have 10. So the process of synthetic division is giving the remainder is going to give you the same result as if you substitute in the value. So again, this is probably the only time we're going to use the remainder theorem to evaluate. You might see a problem like that on your homework, but the reverse of this is going to be helpful for us in the future to substitute in a 0 into an equation to see what the remainder will be. Is going to help us alleviate some time down the road. The next theorem that we're going to take a look at is the factor theorem. And I actually discussed the factor theorem in the first video, but I didn't really put it down into formal writing. So for any polynomial p of x, if p of x equals 0, then x minus c is a factor of p of x. Basically, if x minus c divides a polynomial evenly, it's a factor. If it doesn't, then it's not a factor. So if p of x equals 0, then x minus c is a factor. Sorry, that should not say p of x. If p of, this should say c, let's make this change here. It should say if p of c equals 0. Then x minus c is a factor. And conversely, if x minus c is a factor of p of x, then p of c will equal 0. Essentially, that's going to take us back to the remainder theorem. If we can divide and we get a remainder of 0, then what we divided by is a factor. If it's a factor, then we know that the remainder is going to be a 0. So it says use the factor theorem to determine if each of the following expressions are factors of p of x, where p of x is this given equation. So basically what we want to do here is we want to find out the remainder if we do synthetic division. Now, even faster than finding out the remainder doing synthetic division would be to take this idea of the remainder theorem and realize that substituting in a 2 into this equation gives me the remainder. So what I want to do here for 6 to make this a pretty quick and easy problem is I'm actually going to find my 0. So x minus 2 equals 0. I'm going to add 2 to both sides. X equals 2. I'm going to find p of 2. So if I find p of 2, and I can do this on the calculator, 2 to the 4th power plus 2 to the 3rd power, let me be careful to make sure I type in everything correctly here, minus 10 times 2 squared minus 4 times 2 plus 24 gives me the value 0. So p of c, or p of 2, is equal to 0, which means x minus c, or x minus 2, is a factor. So x minus 2 is a factor of p of x. Now, if I wanted to know what the other factor would be, Now I can do synthetic division. So if I do synthetic division here, my 0 we already found was 2. My placeholders are going to be 1, coefficients 1, 1, negative 10, negative 4, and 24. I'm going to complete the process of synthetic division by adding down the column, multiplying by the divisor, putting that result in the next column. So then I'm going to take 2 times the 3. I'm going to put 6. Negative 10 plus 6 is 4. Sorry, negative 4. 2 times negative 4 is negative 8. Negative 4 plus negative 8 is negative 12. Negative 12 times 2 is negative 24. And then my remainder is 0, like expected. Now the reason I did this is because I can find the factors of p of x. One factor of p of x was x minus 2. We found that to be a factor. Another factor is x to the third power plus 3x cubed minus 4x squared minus 12. So really all of this problem asked was to find if it is a factor. Yes, it is a factor. And then if we want to know what the other factor is, we can do the synthetic division, and the resulting quotient is the other factor of p of x. Let's go ahead and take a look at B. See if you can pause the video and determine if x plus 1 is a factor of p of x. Hopefully you've gotten a chance to do that. So the 0 for x plus 1 would be negative 1. So we need to find p of negative 1. So I'm going to do negative 1 to the fourth power. Then I'm going to do negative 1 to the third power. And I'm going to do negative 10 times negative 1 squared. Then I'm going to do minus 4 times negative 1. And then add 24. My result here is 18. So because I get anything a number other than 0, x plus 1 is not a factor of p of x. So I could divide and do synthetic division to come up with a remainder of 18, or I could find that 0 and substitute that 0 to figure out what my remainder was. It is 18, and when it's anything other than 0, it is not a factor of p of x. So this is the factor theorem is going to be very helpful for us as we progress into graphing polynomials in the next section. The very last thing that we're going to do is we are going to create equations of polynomials given zeros. So this is something that we did with quadratic equations. Now we're going to do this with polynomial equations. So in problem 7a, it says that we have the zeros 3 and plus or minus root 2. So remember, zeros are solutions for x. So x would equal 3, x would equal root 2, and x would equal negative root 2. So if I want to find p of x, I'm going to have at least 3 factors, and we're going to assume that for right now that it's just 3 factors. I'm going to have 3 factors that give me these zeros. So remember, to find the factors, what I would want is the equation equal to 0. So I would subtract 3 from both sides to get x minus 3 equals 0. So x minus 3 is a factor. I would subtract root 2 from both sides to get x minus root 2 equals 0. So x minus root 2 is a factor. I would add root 2 to both sides on the last one to get x plus root 2 equals 0. So x plus root 2 is a factor. Now, to find p of x, we're going to write this in standard form. I want to multiply all of these. So if I multiply these, I'm going to multiply the last 2 together because they're conjugates. Remember, when we multiply conjugates, I can square the first term, subtract, and square the second term. So x squared is x squared minus root 2 squared would just be root 4, which is 2. Now I can go ahead and do some distribution here. So take my x times x squared, which is x cubed. Take my x times negative 2, which is negative 2x. Left a little space here, and you'll see why. Second, take negative 3 times x squared, which is negative 3x squared. And then take negative 3 times negative 2, which is positive 6. So P of x is x cubed minus 3x squared minus 2x plus 6. We can check that if we want to by graphing and then finding those zeros. And we would find that x would equal 3 root 2 and negative root 2. Let's take a look at one more. Problem 7b. So as we examine the zeros here, remember something that we mentioned with quadratic equations. So one of our zeros is x equals negative 2. Another zero is going to be x equals I. Remember, imaginary units, when we're in the solving process with functions, come in conjugate pairs. So if x equals a positive I, then x is going to have to equal a negative I. So then our factors here are going to be x plus 2 as I add 2 to both sides to get the equation equal to 0. X minus I as I subtract I from both sides to get that second equation to equal 0. And x plus I as I add I to both sides of the equation to get the equation equal to 0. Again here, I'm going to go ahead and multiply together my two conjugates, x minus I and x plus I, because those are easier to multiply. It is the square of the first term minus the square of the second term. Remember that I squared has a value, and its value is negative 1. So this is essentially x squared minus negative 1, which becomes x squared plus 1. So now I can distribute. So P of x is going to be x times x squared, which is x cubed, 2 times x squared, which is 2x squared, x times 1, which is x, and 2 times 1, which is 2. So px cubed would be x cubed, or sorry, px would be x cubed plus 2x squared plus x plus 1. If I want to check this, I can graphically. Now, remember that imaginary units are not going to show up on the graph, so we haven't really taken a look at polynomial graphs, but we're going to go ahead and take a look at one here just briefly to check this problem. And as I graph, I'm going to see that this graph does intersect at negative 2, which means it does have a 0 at negative 2. And it's going to have two other zeros, both of them being imaginary units because it is x cubed. Therefore, it would have 3 zeros. So one real that we can see on the graph and 2 imaginary. And this is the end of the lesson here for target PF.1 as we took a look at polynomial division and its uses, and then just took a brief exploration of multiplying polynomials to come up with polynomial equations in standard form. The next time we reconvene in class, we'll have the opportunity to look over some of these questions, or look over some of these problems, answer some questions, maybe provide some extra examples, and then get some practice on the homework. As always, thank you guys for tuning in, and I will see you soon.